Okay, now I am in a position to start specifying my correlation structure. Now the correlation structure that I will work with will be AR1. There are lots of correlation structures. I am going to tell you about them, but for the time being. So you start writing like this. You give it a name, CS1. I have called it correlation structure 1. Core AR1 is their name. So they all start with the 3 letters, COR, core. AR1, so you can remember what that was. All the diagonal entries are same. Since it's correlation, diagonal entries are all 1. And all the off-diagonal entries are equal to some row. In this case, I have taken that value of row to be 0.8. Just arbitrary thing. Now comes the most weird part. What I want to say is that for each layer of fertilizer, that is for all the cases where J is the same, they are all correlated. So I am really creating those blocks. Now the way I wrote in the last video, you saw that a block structure need not remain like a block structure in the overall matrix of covariance of epsilons, because the blocks may be scattered all over the place. And the resulting matrix is a very sparse matrix. Most of them are zeros. So storing that huge thing is not a very efficient way of storing. So what R does is that it will store the covariance matrix separately for different such layers. So the way to specify that is this: you write form equal to, that is the name of the parameter. Surprisingly, you have to write tilde. There is nothing before the tilde. What you write after the tilde actually doesn't matter. So you always write 1 here. It does matter in a rather subtle way, but for most applications that you are going to do, you do not have to care about that. Then you put a vertical bar, that is the blocking factor, so the under which the blocks are there, and then you write fert for the fertilizer, so you get blocks for fertilizers. So very weird sentence. So let us see what is happening. So I do this CS1, and if you try to print CS1, nothing interesting occurs. It merely says correlation structure of plus core AR1 representing phi 0.8. Incidentally, I just made a long statement. I said that all the off-diagonal entries are same. That was for compound symmetry. When you are working with AR1 structure, it means the upper diagonals are 5, 5, 5, 5, 5, then 5 square, 5 square, 5 square, 5 cube, 5 cube, 5 cube, and similarly in the lower triangular half. So that is the thing, and you are going to see that in a moment. Now, you naturally want to see the matrices, but this does not show you the matrices. To do that, we have to call this function which is called initialize, a weird function that you will not need to call when you do the actual analysis. It is just for visualizing the thing. So you write cs1.show initialize CS1, this is the structure, and now you have to specify the data, because here I just write FERT. I do not even know what FERT is. I have not specified the data. So I will do that, and that creates the actual matrix. If you want to see that, you have to execute the command core matrix cs1.show, and that will give you the final thing that you wanted. So let's quickly see what we got. So I had got 2 different fertilizers, none and compost. So this thing consists of 2 lists, consists of a list with 2 elements. The first one is devoted to none, the second one is devoted to compost. And you see, this is your covariance matrix evaluated for phi equal to 0.8. So nothing is fitted yet. It is just a structure. You can see the structure. You see all the diagonals are 1, then the super diagonals are 0.8, 0.8, 0.8, 0.8, that's the value of phi. Then the one above that is 5 square, 5 square, 5 square, 0.64, 0.64, 0.64, 5 cube, and 5 to the power 4. The same pattern repeats on the lower triangular half. Observe the same thing happening in case of compost, but since we deliberately made the data unbalanced, the size is different. So it keeps the structure and creates the size based on how many occurrences are there for each of the factors involved. Now, if we want to do the other way around, as you see, in this case it goes further. 5, 5 square, 5 cube, 5 to the power 4 and up to 5 to the power 5. So it grows depending on how many layers you have kept. Okay, so suppose we want to do not for fertilizer but for variety. So I create another structure CS2. That's my name, arbitrary name. Core AR1, the same structure, 0.8. Form is, again, this part is just rubbish. It's always to be there. This part up to tilde, 1, vertical bar. Variety is the blocking factor. And then I again do the same thing. I initialize it and let's just see what happens. Now the matrix is like this. Joya, we had got exactly 3 cases under Joya. So that's a 3 by 3 thing. We had exactly 4 cases under Taichung. We have a 4 by 4 thing. We have 4 cases under IR8. This thing, but all of them involve the same file. Only the order of the matrices are different.